Right, so here now we've got a box and a bag contain coloured balls, identical except for their colour. When a ball is drawn at random from the box, the probability that the ball is blue is 3/5. When a ball is drawn at random from the bag, the probability that the ball is blue is 2/9. Howell draws one ball at random from the box and one ball at random from the bag. So you've got your box, okay, and you've got blue balls. They've given you the probability that it's blue in the box. It says up there, doesn't it? The probability that it's blue is 3/5. Okay, 3 out of 5. Now, if the probability of it being blue is 3/5, not blue, of course, will be 2/5. It's what's left over, if you think about it. Okay. Now, when we go to the bag, then you've got the probability of it being blue is 2/9. So we can write 2/9 here. All right. Not blue, of course, then, if you think about it, well, blue 2/9, not blue, then we've got 7/9. Okay. That's already been filled in for us. So also then, of course, we can have 7/9 down here. Now, part A then says calculate the probability that neither of the balls drawn is blue. Okay, so the probability that neither of them are blue. So that means in the box it can't be blue. So we go along this path, and in the bag it can't be blue. So we go along this path. So that's the only way we can do it. We got this and this. In other words, not blue and not blue. So you've got 2/5. And so we're going to times 7/9. Okay, so that's the only option I'm interested in there. This and this. We times them. So when you times them, you times the top, 14, times the bottom, you get 45. Okay, and you've got your answer there. So we can write that down here as well. And we're done. Question 2. It says a game involves 2 bags, each containing coloured balls. Bag A contains 1 red ball and 4 yellow balls. Bag B contains 2 red balls and 1 yellow ball. Player picks 1 ball at random from each bag. Complete the following tree diagram. So, bag A, for it to be red, you got a 1 in 5 chance. Because if you look here, 1 red ball, 4 yellow balls. Well, there's 5 balls in total, isn't it? 5 balls in total. So you've got 1 out of 5 for getting red. Yellow then, of course, it'd be 4/5, wouldn't it? Because 4 of them are yellow. Now, when it comes to bag B, right? When it comes to bag B, we look at what we've got here: 2 red balls, 1 yellow ball. So we've got 2 chances out of 3, because there's 3 balls if you think about it in bag B. So 2 chances of getting red out of 3. Yellow ball be 1 out of 3. And we repeat it down here then. Okay, we repeat the branch down here. Okay, part B then, it says find the probability of picking 1 ball of each colour. Okay, if you think about it, 1 ball of each colour. You could have red, yellow. Okay, so you could have red from bag A, yellow from bag B, or you could have yellow and red. Okay, yellow from bag A, red from bag B. Okay, 2 different options. So red 1/5, yellow 1/3. So you're going to times them together. So you get 1 on the top, 15 on the bottom. Or yellow in bag A, red in bag B. So 4/5 times 2/3. So you get 8 on the top, 15 on the bottom. Alright, so you can copy that down here. Or, of course, it means we're going to add them. This is, we have more than one option, more than one possible way of doing this. So you get 1/15 plus 8/15 is 9/15. Okay, and we've got our answer. One more. It says when Dylan has lunch, probability that he has a dessert is 1 out of 4. Whether or not he has a dessert, the probability that he has a coffee is 2 out of 5. Complete the following tree diagram. So if he has a dessert, it's 1 out of 4. So not dessert will be 3 out of 4. Has a coffee, 2 out of 5. So not as a coffee will be 3 out of 5. Okay? And then we just repeat this here. Calculate the probability that Dylan has a dessert or coffee, but not both. So you could have a dessert or coffee, but not both. So that means you could go along this branch as a dessert and not a coffee, because you can't have both, can you? It says here not both. So you can't have dessert, coffee. That's out of the window, so to speak, because you can ignore that one. But you could have dessert, not coffee. So that'll be 1/4 times 3/5. So that'll be 3 out of 20. Or you could go along here, does not have a dessert, has a coffee. So 3/4 times 2/5, which would be 6/20. Okay. And then if we go along this branch here, well, we can't, can we? Because that would mean he doesn't have dessert, doesn't have coffee. So that's a no-no. So there's two different ways, two different routes. It's this or this. So you just simply need to add them together. And if you add them together, of course, then you get 9/20. Okay? So you can put all that working down here and you get 9/20 as your answer.